So here we'll be trying to figure out the derivative of p with respect to the time variable t using that given equation that we have. Now, how do we differentiate this one? So as you can see, just ignoring 40 for a second because we know that derivative of a constant is 0. The equation we have, a fractional equation, we could actually use the quotient rule. And if you remember, the quotient rule, we need two variables, u and v. And it's given by v times the derivative of u minus u times the derivative of v all over v squared. Okay? And at this stage, we just have to label the u and v. So I personally, and pretty much every single math textbook does, they label the top half u and the bottom half v. And here we are. Now, to differentiate u, simply to differentiate exponential, we literally differentiate the power part minus 0.1 t and just drop the 0 minus 0.1 down and multiply it to the 100. And that should give us negative 10. And of course, we copy the exponential part. Likewise, for v, differentiate 1, you get nothing. Differentiate 3 to the power minus 0.9 t, well, you drop minus 0.9 down, times the 3, you should get minus 2.7. And of course, the exponential part. And that's it. Now we just plug all of that into the dp over dt equation. And we should get the following. So, I mean, it's all a matter of construction. I try to be quite skillful with it. So, if you're dealing with a longer term with 1 plus or minus something, I tend to put that second. So v times u prime, I did minus 10e first. I did u prime times v first because it's just easier to write. And minus, so notice that you got negative 2.7 for v prime. Well, if it's a negative, I'll put that first before the u. So I'll plus 2.7 e to the power negative 0.9 t. Then I times this against u, which is 100 e power minus 0.1 t. And literally smash this all over v squared. And v squared is just 1 plus 3 times exponential all over power 2. And literally this is the end of the answer. Now all they really want you to, all that you're probably expected to do is just tidy the top line. So first things first, let's expand the brackets and multiply out the right hand side. So we should get minus 10e power minus blah blah times 1 is the same, minus 30e to the power minus t. So remember, minus 0.1 t times minus 0.9 t, you add the power, so minus 0.1 plus minus 0.9 is just minus 1, so just minus t. And likewise, plus 270e negative for the same reason. Oh man, that's a lot, right? It's a lot of reading, guys, isn't it? So just have a look. Next one, so minus 30 plus 270 give you 240e minus t, and of course minus 10e power negative 0.1 t. And lastly, we can factorize 10e minus t out, and we should get the following. Voila, that's it. Man, this can really drag your breath out. So I hope this helps, guys, and for those continuing, get ready for part C. Alright, what do we have here? So it states that the number of rabbits initially increases, reaching a maximum value given by pt, as we saw earlier in the graph, when small t equals capital T. So capital T is clearly the maximum. So using your answer from part B, calculate the following. The value of t to 2 decimal places and the value of pt to nearest integer. So really, let's understand this. So when we differentiate, firstly, we should understand that the curve we saw in figure 3 is literally the turning point. And this turning point for any derivative, any shape, is always when the gradient is 0. And we know that the first derivative is the gradient. So setting that to 0, we have the dp over dt equal to 0. Therefore, we can solve that equation. So notice that this bottom half of the fraction multiplying against 0 will cancel out. And you're just left with the following, 10e minus t times 24 minus e to the power 0.90. So the first solution, 10e to minus t equals 0, is no solution, of course, because taking logs, well, you can't have a log 0. Ignoring that, so taking the second solution, 24 minus e to the power 0.90 equals 0, well, just doing a quick algebra, plus an exponential across and then taking logs and then dividing by 0.9 should give us ln 24 over 0.9. And friends, this should give you 3.53 years. and that's it. Plugging in the value of t into the original p equation should finally give us roughly 102. So can you guys check that for me? Because again, these are model answers, but either way, the methodology should be fine. Now let's wrap this up with part D. Part D should be quite easy.